Hi, my name is Kiran Baburaj. Welcome to Career Campus Pro YouTube channel. Have you ever wondered how computer keeps the track of undo operation or how it manages the browser history? Well, get ready to unlock one of computer science's most elegant solutions, the stack data structure. Imagine a stack of books on your desk. You can only add or remove books from the top, right? This simple concept is exactly how a stack data structure works in computing. It follows the LIFO principle, last in, first out, just like the stack of books. The last item you put in is the first one you will take out. So the stack is a linear data structure where items are added and removed from the top, following the LIFO principle. Think of it like a vertical tower of data. Each piece of information or element sits on top of the one before it. The top element is the one that is recently added and the bottom element is the first one added. Now let's look at the three main operations you can perform on a stack. First we have the push. This is how we add new elements to our stack, just like placing a new book on top of the pile. Next is pop. This removes the top element. Remember the LIFO. The last element we pushed in is the first one we can pop. Finally, there is peek. This lets us look at the top element without removing it. It's like checking which is the top element in the stack. There are two main ways we can implement a stack in code. Array-based stacks use continuous blocks of memory, just like rows of boxes next to each other. They are fast but have the fixed size. The next is linked stacks. On the other hand, they are more flexible. Each element points to the one below, just like a chain. They can grow or shrink as needed, but takes up a bit more memory. The real magic of stacks shows up in their applications. They are everywhere in computing. Your web browser uses a stack to manage the back button. The programming languages use stack to keep track of the function calls. The text editors use them for undo or redo operations. Even the process of checking if the brackets in your codes are properly matched relies on the stacks. Here is the best part about the stacks. They are incredibly efficient. All basic operations, push, pop and peek, take constant time, which is order of 1, which means that no matter how big the stack is, the operations always get the same amount of time. Now let's break down the key difference between the stack and queue. Let's start with the fundamental principle. Queue follows first in first out FIFO and stack follows last in first out LIFO. Queue adds elements at the rear and stack adds element at the top. Both queue and stack remove elements from the front. Queue have enqueue dequeue operations and stack has push and pop operations. All have order of 1 complexity. If you found this video helpful, please don't forget to like and subscribe. Happy coding. Thank you.